We're asked to calculate energies and we're given wavelengths represented by symbol lambda. We're going to use a couple equations here. We know that energy is equal to Planck's constant times frequency. We also know that the speed of light is equal to the product of wavelength and frequency. We can rearrange that, isolate for frequency by dividing through by lambda, the wavelength, and you get speed of light over wavelength is equal to frequency. We can plug this in, substitute it right there, and what we get is that energy is equal to Planck's constant times the speed of light over wavelength. So that's the equation we'll use for A, B, and C. I'm just going to go ahead and punch these in the calculator. 6.626 times 10 to the negative 34 times the speed of light is 2.998 times 10 to the 8 divided by the wavelength given in A is 1.2 times 10 to the negative 4. That's our energy in part 1. It only has 2 significant figures in all of these, so we'll say it's 1.7 times 10 negative 21 joules. All right, joules is the unit for energy, and so over here the unit for Planck's constant is joules seconds, speed of light is meters per second, and then wavelength is in meters. So that's going to cancel out. That's going to cancel out. You're going to be left with joules, which is the SI unit for energy. All right, I'm just going to go back to my calculator and copy what I had up here and just switch out the wavelength. So 5.1 times 10 to the negative 7. Energy in the wavelength in part B is 3.9, because again we're doing 2 sig figs. 3.9 times 10 to the negative 19. All right, part C, copy that thing again. All right, and I'm just going to replace the wavelength to 1.4 times 10 to the negative 8. All right, so as you can see, as the wavelength gets smaller and smaller, the energy gets larger and larger. So that's going to answer our last part of the question here in a minute, but it's 1.4 times 10 to the negative 17 joules. All right, the answer to part, just call this part D if you want. What's the relationship between energy and wavelength? So all of these, the wavelength is increasing, okay, increasing as you go down. That's confusing here. As wavelength, which is represented here by lambda, all right, as wavelength increases, I'm sorry, they're decreasing in this from A, B, and C. I'm confusing myself. As the wavelengths get shorter and shorter, all right, they're getting, this is the longest one, this is the shorter one, that's the shortest one. So as wavelength gets shorter and shorter, what's going on with the energy? It's getting larger, larger, larger. So they're inversely related. All right, so wavelength is inversely proportional to energy. One goes up, the other goes down. You could say the other is also true. Energy is inversely proportional to wavelength. The one goes up, the other goes down.